Hello everybody, Mr. Baker here again. Today we're going to talk about the factors that affect electrical resistance. So first of all, we're going to identify what factors affect that electrical resistance. And the first one that we need to look at is something called resistivity. And resistivity is really the substance, what the actual conductor is made of, how hard or how easy it is for the electrons to flow through that particular piece of wire. We also need to look at the length of the conductor as well, if it's a short piece of wire, if it's a long piece of wire. We also need to look at something called the cross-sectional area, and that really is just the thickness of the conductor, if it's a thick piece or a thin piece of wire. And we can lump all those together and say that the resistance is equal to the resistivity times the length divided by the cross-sectional area. And if we put that into symbols, is R is equal to rho, and this little symbol here is rho, it's a Greek symbol for resistivity, times the length divided by A, so rho L divided by A. So let's look at each one in turn. First of all, we're going to look at resistivity. Now, if you remember from previous lessons, the substances are made of different atoms. You know, gold is made of gold atoms, carbon atoms, and so on and so forth. And different metals are made of different types of metal atoms. And those different atoms hold on to their electrons either tighter or looser than some other atoms. So we talked previously about the fact that you've got conductors and you've got insulators. And conductors allow those electrons to move through the substance because they are loosely bound. The electrons are loosely bound to their parent nuclei, and with insulators it means that they are strongly bound to the parent nuclei. And that means that those electrons are not free to flow through the circuit, and we call that factor the resistivity, how easy or how hard it is to flow through. So here's just a little diagram. You can see that there's a bond between the parent atom and the electron. So here's the electron here, okay, and this one here, the electron is free to move inside the conductor. The other thing that we need to consider as well is the length of that conductor. So we have those red parent nuclei there and the blue electrons moving through the substance. And with a short piece of wire, it's a low resistance. And the reason for that is because if you've got a relatively short piece of wire, there's less of those atoms for those electrons to be attracted towards, so they find it much easier to get through. There's less obstruction, okay? But if you have a longer piece of wire and you have lots of those nuclei in the way, and that means then that those electrons have more obstacles to go through. Okay, consider it like an obstacle course. It's difficult for those electrons to get through because there's more ions in the way. So the longer the piece of wire, the greater the resistance. The shorter the piece of wire, the lower the resistance. And lastly, really, we'll want to look at something called cross-sectional area, and that is basically the thickness of the piece of wire. So let's take two pieces of wire. Same again, we stick our ions in there and we stick our electrons in there. And if you look at those two pieces of wire, the thinner piece of wire, well, there's less gaps for those electrons to get through. Okay, it's harder for them to get through because there's less space for them to move through. The thinner piece of wire doesn't allow them as much of them to move through. And the other thing as well is that there are, for the same length, there are less of those electrons, so the current is lower, so the resistance is greater. With a thicker piece of wire, even though there's more ions in that particular piece for the same length, but there's more gaps, it's easier for those electrons to get through, and there's more electrons, more free electrons for the same length of thinner piece of wire. So with a thicker piece of wire, it's easier for the electrons to get through, so there's less resistance. With a thinner piece of wire, it's harder for the electrons to get through, so it's a greater resistance. Let's summarise our findings then. First of all, we said that if we increase the resistivity, that is the substance inside the wire, how hard it is intrinsically for those electrons to get through, we increase the resistance in that circuit or that conductor. Secondly, we said that if we increase the length of that piece of wire or that conductor, then we increase the resistance. And then lastly, if we increase the cross-sectional area, and this is the one that's different to the other two, if we increase the cross-sectional area, in other words, we increase the thickness, we decrease the resistance. And that's going to be important for your project coming up in the next couple of weeks. And I hope that was helpful.